Hi there, this is just a little video I'm doing here on an introduction to graphing lines. And the reason, or what is a graph anyways, the reason I'm doing this is because very often students are working through the first time they are introduced to this idea of graphing lines. And they get partway through the chapter, or sometimes even all the way through the chapter, and then they get a hold of me and they say, "Hey, I can like get all the right answers. I can make it work. I can draw the line. I don't have a clue what any of this means. It seems like I'm just drawing random things, following random rules. I don't understand what's going on." Another really common thing that comes up is at a certain point, people say, I can follow through all the steps that the book is showing, but it, it seems like they're just picking any number they want to. Like how you can just pick anything you want to. Won't everyone get a different answer, they think? So I'm kind of going to try to address those two really common things that come up with this. So the answer to that question right there, what is a graph when we get into drawing graphs of equations? The graph is actually the answer to an equation when there's two unknown variables instead of just one. And I really mean that. It is the answer. So in the same way that if we go back to an equation with just one variable, so here's an equation with one unknown, right? X, we don't know what X is. We want to find out what X is, and I picked a nice easy one, so without doing a whole bunch of complicated equation solving, we can probably see there that X is 7 is the value that will make that equation true. 7 plus 3 equals 10. So the answer to that equation is X equals 7, because X equals 7 is the only value that will make the equation true. 7 plus 3 is 10. If you put in something different for X, like 8, you'll get 8 plus 3 on the left, which is 11, which is not equal to 10. So the left and the right would not be equal. Only 7 will make the left and the right equal, which is what solving an equation means. Okay, so let's step that up now. And instead of just having one thing we don't know, we're going to have two things we don't know. We're going to call them X and Y. It could be anything. And there's a random equation I picked with two variables. You can see it's very similar to the last one. X plus Y equals 10. And so we want to find any values of X and Y that will make the left side equal to the right side. And because I kind of picked one similar to the last one, you might notice that 7 and 3 would work, right? 7 plus 3 is 10. So you notice if we replace the X with a 7, we replace the Y with a 3, we get a true statement. 7 plus 3 equals 10. True. But you probably also would notice that that's not the only one, right? So for example, 5 and 5, that works too. 5 plus 5 is 10. If you replace X with 5 and Y with 5, you get a true statement. Keep going. If you replace X with 2 and Y with 8, you get a true statement. Can you just hold on for 1 second here? Sorry. I'm back. Sorry about that. Just had to switch something. And we could keep going. How about X equals 10 and Y equals 0? That works, right? Nothing wrong with Y being 0. So 10 plus 0, we get a true statement. And so that's getting a bit cumbersome listing all of our answers like that. So how about we try putting them in a table instead? It'll save us a little bit of time. So something like this, where we're going to list X's and the Y that goes with them that makes X plus Y equals 10 true. There's the ones we had already. 7 plus 3 is 10. 5 plus 5 is 10. 2 plus 8 is 10. 10 plus 0 is 10. Let's keep going. Hey, that 0 was kind of handy. What if we swap that around? 10 plus 0 is 10, but also 0 plus 10 is 10, right? So if we replace X with 0 and Y with 10, we get a true statement here. Now, so far, we've got all whole numbers there. Who said that X and Y have to be whole numbers? Nobody. So how about something like 8.5 plus 1.5? Why not? Those two numbers add up to 10, right? So that is another solution to this equation. All of these here, every single pair is a pair of X and Y that makes the equation true. It's a solution. What about fractions? Sure, no problem. 5 and a third plus 4 and 2/3. If you add those together, you get 10. Or if we get really ugly numbers, there are these big long decimals. If you try that out, you'll find that those two numbers do indeed add up to 10. So if you replace x with 3.79132 and you replace y with 6.20868, you will get a solution to this equation, an xy pair that makes the equation true. So far they're all positive numbers, but who's to say we couldn't have, something funny happened with my table there, that's okay. We couldn't have negative, so y is negative 2, x is positive 12, add them together, you get 10, that one solves the equation. There, my table fixed itself. Or we could get really, really big numbers, right? 4,235 plus negative 4,225, that adds up to 10. And I think you see by now, I could go on and on and on all day, and I would never get even close to having all of the solutions for this equation that make x plus y equal 10 true. So how are we possibly going to write an answer, right? In that question before, x plus 3 equals 10, there was one answer. It was easy. X was equal to 7. But now we have an infinite number of xy pairs that make the equation true. And somebody at some point had the crazy idea. They're like, well, what about this graphing stuff we do where we put xy points on graphs? What if we put all of these points here that we've got, all the xy pairs that we make this particular equation true, what if we pop them onto a graph? Like so. So you can see, for example, our first one, x is 7, y is 3. Start at the origin. There is x is 7, y is 3. There's that point, right? And similarly for all the rest of them, I didn't put all of them on there. This one down here doesn't fit, right? This one here with the fractions, I couldn't make the program write fractions nicely on the graph, so I just didn't bother, but it's on there too. In fact, let's check it out. 5 1/3 x and 4 2/3 y. It would be right about there. And what you notice is that all of these points for this particular type of equation happen to fall on a straight line, which we could draw right through it like that. And now back to what I was saying, 5 1/3, 4 2/3, look at that is also on that line. Other points that we didn't actually list in our table of values but do make the equation true are also on that line. Look at this, x is 1, y is 9, right there, the point 1, 9. 1 plus 9 is 10, makes the equation true, right? So if we just get rid of the specific points we did and just draw this line, here's the key piece of information for what a graph means. That picture you're looking at right there is the answer to this equation here, x plus y equals 10. How is it the answer? This line shows every single xy pair that will make that true. Forever, we could keep with this line going forever down there and forever up there. It would show every single pair that makes the equation true. So just to reiterate, is the answer to the equation x plus y equals 10. So just to reiterate, if we go back, there's an equation with one variable, x plus 3 equals 10. It has one answer, x equals 7, the only value in the universe that will make that equation true. But when we have an equation with two unknown variables, there is the answer. A picture of all the xy pairs that make the left side of that equation equal to the right side, make x plus y equal to 10. Okay? Now, yes, so just to really drive this point home, this goes both ways. Any point that makes the equation true is on the graph. For example, 8 plus 2 makes the equation true, right? X is 8, y is 2, 8 plus 2 is 10. And sure enough, there it is on the graph, 8, 2. Or turn it around. Any point that is on the graph makes the equation true. So let's pick some random point on the graph. How about that one right there? When x is -1 and y is +11. There's a point on the graph, right? Does that point make the equation true? -1 plus 11 equals 10. Yes, it does. Every point on the graph makes the equation true. Every point that makes the equation true is on the graph. That is why this picture is the answer for that equation. It shows all of the solutions. Okay, So we've already said this, the solution to an equation with two variables can be represented with a picture. For now, you're only doing equations that end up in straight lines, but later on you'll end up seeing equations that create all kinds of weird shapes by putting different types of things into those equations, powers and roots and all kinds of stuff, fractions. So in order to graph a line, here's the next key point I want to make. We found a whole bunch of points there, right? And made that big table of values. We didn't need to find 8 points or 10 points or whatever. We really only needed 2, because if it's a line, you just need 2 points. And if you're doing it by hand, say you pick up your ruler and draw a straight line through them. Any 2 points on that line, and you can draw it. So just going back to the example we've already done, let's say instead of finding 10 points or whatever it was we found, let's say we just identified those two. 7 plus 3 is 10, yep. 0 plus 10 is 10, yep. Just put those 2 points on the graph, there they are, and draw a line that goes through them, and boom, you have your answer just like that. So we don't need a giant table of values, we just need 2 definite points on the line in order to draw it. Okay, so we're going to try a few here. So working from that starting point that we can draw the line if we can find 2 points on it, and the way to find 2 points on it is to find any 2 xy pairs that make the equation true. Because that's what the line is. It's a picture of all the points that make the equation true. So here's a nice simple one. I'm going to do 3 here. If you watch the first one and you think, okay, that's really easy, careful, I would suggest you do watch the second 2 as well, because there start to get a few little tricks with how you find these points after the nice easy ones. This one is easy for a couple reasons. There's no fractions in the equation as it is, and also it's isolated for y. So when it's isolated for y, we can just plug in x's and calculate the y that goes with them. Sometimes we'll have to do a little more work, and that'll come up in the next example. So let's set ourselves up a little table of values. Our goal here is to find 2 points that make that equation true, and we are going to try and, now, we could pick anything we want here as an x, right? But why would we pick a complicated number when we could pick a simple number? So how about 0? And now here is the moment when students say, wait, how can you just pick anything you want to? Won't everyone get different answers? And yes, everyone will get different y's that go with their x's if they pick different x's, but they will all get points that are on the line, the same line, right? So could I pick x equals 2.739186? Sure, but why would I when I can pick x equals 0? Could I pick x equals 5 7/9? Sure, but why would I pick a complicated number when I can pick a simple number? And even if students pick different numbers, they're not just picking different numbers, they're also then calculating the y that goes with whatever number they picked to find a point on the line. So let's do it. I'm going to plug in x equals 0. 2 times 0 is 0. That's nice and easy. 0 plus 3 is 3. So isn't 0 a handy one? Because there we go. That 3 was supposed to turn blue and it didn't. Sometimes that happens. Anyways, you get the idea. There is one of the points that we know is on this line, 0, 3. When x is 0, y is 3. That's a point on the line. Now let's find another point. And again, I mean, you might as well go simple, right? What's another simple number for x? How about 1? Why not? Could we pick something more complicated? 3.7? Sure, but why would we when we can pick something easy like 1? And then either way, we would calculate a specific y value that goes with that x value and get a point that is on that line. So 2 times 1 is 2. Add 3 is 5. And pop that into our chart. Yeah, none of those y's, you're going to see this over and over. For some reason, it's a weird little glitch that y is not turning blue like I set it to. So there we go. 2 points that are on the line, 0, 3, and 1, 5. Made one of them red and one of them blue. And there they are on the graph, red and blue, 0, 3, and 1, 5. Now that we have identified 2 points that are on the line, you can pick up your ruler if you're doing it by hand, or if you're using a tool like MyOpenMath or MyMathLab. Once you have those 2 points plotted, it'll draw the line through them for you. And there it is. That line is the answer to the equation y equals 2x plus 3. Every point that is on this line makes this equation true. Every point that makes this equation true is on this line. Now we happen to do these two. Let's just drive home the fact that if you had picked different x values, it wouldn't matter. So what are a couple other x's we could have chosen? There, okay, it's got a weird effect on my screen swaps right now. That's all right. So we could have chosen x equals 2. And you see down here I plugged in x equals 2, and you can follow through the work. I got out y equals 7. Take a look here, 2, 7. That would have worked just as well, right, if we had got that point. Or if I had picked x equals -1, I would have got out y equals +1. 2 times -1 is -2, plus 3 is 1. And x equals -1. Look at that. That point is on the line. That would have worked just as well. Or if I had picked x equals -2, I would have got out y equals -1, x equals -2, y equals -1. There it is right there. Using that point would have worked just as well. And there, I think I plot all those on that graph. Any of those would have worked equally well for this question. Any two of those, right? We happen to do the red and the blue one. We could have chosen any two of those x's, and we still would have got 2 points on the line and gotten the same exact picture. Okay, let's try another one that's not quite so straightforward. So here you see we have another equation, 3y minus 2x equals 12. And unlike the last one, we don't have y isolated. That's fine. We can still plug in anything we want for x or for y, and then solve for the other one using how we know how to solve equations. And you'll see I have a little note up at the top there. We want to find nice points. We want to avoid fraction points because it's really hard to graph accurately a fraction. You want nice whole numbers if you can possibly get them. So again, let's start with x equals 0 because that's a nice simple place to start. We'll replace the x with a 0, and we're going to solve that equation for y. And you see we're going to actually have to do a few steps here. So 2 times 0 is 0. That's nice. So on the left, we're just left with 3y, and on the right, 12. We solve that equation by dividing both sides by 3, like so. And the 3's cancel on the left, so we just have a y. On the right, 12 divided by 3 is 4. And there is a nice point when x is 0, y is 4. Great. Let's get another one. We get one more, we can draw the line. Last time we did x equals 1, and that seemed to work great, so why don't we try that? Plug in the 1 for x. 2 times 1 is 2. So 3y minus 2 equals 12. We have to add 2 to both sides. 3y equals 14. And I'm breezing through the equation stuff pretty quick because you've all done the equation solving chapter already. We solve this by by dividing both sides by 3. And oh dear, now we have a problem. 14 over 3, well, that's 4 2/3 if you write it as a mixed number. That is yucky. I think I put that there. Yes, yucky. Now you see I put it in my table of values. I mean, it's a legitimate point when x is 1, y is 4 2/3, but how are you going to accurately draw that? Because that 4 2/3, that's 2/3 of the way between 4 and 5 for your y value. You're not going to be able to put that on the graph accurately. So let's go back to the drawing board and try to find a point that doesn't have a fraction in it. And if you muddle around a little and try a few, you'll eventually possibly find that if you put in x equals 3, it works out. Or you might have found a different one that works. There are a bunch of them. So if we do put in x equals 3, 2 times 3 is 6. Add 6 to both sides, add 6 to, okay. That 18 right there is a typo. My apologies. That should have still been a 12 right there. Is a 12. 3y equals 18. Divide both sides by 3, like so. And you get y equals 6. There we go. So there we found an answer which is a whole number. And this would work. I'm actually not going to use these 2 points because I want to show you maybe a slightly better way to do this. But if you wanted to plop those 2 points in the graph, draw your line, you would be done. Now, the thing that was not good about that is that we had to fish around a bit. You maybe had to do some trial and error to figure out eventually that 3 worked without giving you a fraction. Something that will often, but not always, be helpful is taking advantage of this 0 thing. Now here we plugged in x is 0 and we got out a y value that happened to be a nice number, which is great. There's nothing to say we can't start from the y. Plug in y equals 0 because 0 makes everything easier, right? Now you might still end up with a fraction, in which case you got to go back to the trial and error to eventually find a point that doesn't have a fraction. But boy, it's a lot easier to stick a 0 in than to stick in any other number. So let's try this. Notice I put the 0 in for y now, and let's find out the x that goes with it to make the equation true. 3 times 0 is 0. That's nice. Divide both. No, so then, just 0 just goes away. Divide both sides by -2. So it cancels on the left and becomes -6 on the right. So this should be read -6, 0. And why don't we do a quick little double check here. We're claiming that when x is 0 and y is 4, it makes the equation true. So when y is 4, 3 times 4 is 12, minus 2 times 0 is 0, so 12 minus 0, that's 12. How about this one? When y is 0 and x is -6, 3 times 0 is 0, -2 times -6 is positive 12. Look at that. And also the other point we did there, I'm trying to remember what it was now. It was x is 1, and we got y is, I can't remember right now. So let's not worry about it. No, it was x equals 3 and y equals 6, right? Is that what it was? Yeah. So the other point that we had previously was x equals 3, y equals 6. Look at that. 3 times 6 is 18. Minus 2 times 3 is 6. So 18 minus 6 is 12. All the points we got make the equation true. But the two we're going to use here are 0, 4 and -6, 0 from this chart. There I put them on the graph, -6, 0, 0, 4. Because as long as I got 2 points, I can draw the line that goes through them. And there I have the line that is the answer to that equation. It shows all xy pairs that make it true. And do notice x is 3, y is 6 is on the graph as well. That's the other point we found that we could have used instead. Any two of those 3 points would work. Or there's other ones you might notice that you might have found. Right there, -3, 2, for example. Or up here, it looks like 5, 8 is probably another one too. Okay, let's do one more. Notice this one has a fraction in it right off the bat. So we're going to have to try and work our way around finding answers that don't have fractions in them so we can draw the points. Always starting with x equals 0 is likely to be a good place. So we plug in 0 for x. Third times 0 is just 0, and look how easy that was. There's our first pair. When x is 0 and y is -1, it makes the equation true, so that is a point on the graph. Again, you might try, x is 1. That worked that first time. It was really easy. Let's try it. A third times 1. Now we remember when we multiply fractions that a whole number has to become a number over 1, so 1 becomes 1 over 1. Multiply the tops, multiply the bottoms. 1 times 1 over 3 times 1 is a third. And we have a problem. If you did a bit of fraction work there, I haven't done it here, but if you change that 1 into 3 over 3 to get a common denominator, then you subtract, you get an answer of negative 2/3. I put it in the chart because it's a legitimate point on the line when x is 1, y is negative 2/3. But it is not a point that we want to try to graph because we're going to be guessing where exactly it goes. So back to the drawing board. Now you might notice that what caused that fraction was this 3 on the bottom. So if we could put something on the top that is divisible by 3, we would solve that problem. 3 would probably be the easiest choice, but just to show you that anything that's divisible by 3 works, I picked 6. A third times 6 minus 1, so we put the 6 in for x. And then again, remember that if we multiply fractions, we have to turn this into a fraction. 6 is 6 over 1. Some students are still tempted to multiply the 6 into the top and the bottom, which is not correct, remembering your fraction work. 1 times 6 on the top, 3 times 1 on the bottom, that's 6 over 3. Well, 6 over 3 is just 2, and 2 minus 1 is 1. So there is our y value, 1, that goes with the x value of 6. If we had picked x equals 3, we would have got a different point, which is also on the line, and we would get the same picture in the end. So there's the 2 points we're going to use, 0, negative 1, and 6, 1. There they are in the graph. And once you have 2 points, you can just draw the line that goes through them. If we had picked x equals 3, by the way, we would have got y equals 0, which would be that point right there. And when we joined our line, we would get the exact same line, even though we had picked a different x value to start. And I think that is the end. Yeah, so hopefully that gives you a bit of an understanding of the big picture of what's going on with graphing and how to graph by finding 2 points. As the chapter goes on, you're going to learn different methods for finding 2 points to graph based on the properties of the line instead of just this kind of trial and error method we're doing here. This is just to get the hang. And I was going to say that those other methods are shortcuts, but often they're not. Often they're actually longer, but they have value for other reasons that you'll see towards the end of the chapter. Sometimes the quickest way to get the graph of a line is exactly what we're doing right here. Just pop in a couple points, get a couple xy pairs, put them on the graph, boom, you have a picture of the line just like that. Good luck with all your work, and let me know if you have any questions.